So good afternoon, everyone. Today's session is based on sheet metal. So what is sheet metal? Anyone? What is sheet metal operations? So sheet metal operations are generally used to prepare cabinets, to prepare outside parts of machines, covers, etc., and so on. Okay. So sheet metal modeling is different from normal modeling. So all of you know how to open this Creo interface. Okay, so you need to go to startup menu and select Creo parametric. So in the Creo parametric, you have to click so that you will get this Creo interface. Okay, so in the Creo interface, you select this label called new button. So if you click new, you will get a pop-up window. In that you have type as part, and in the subtype you select sheet metal. Okay, so in the subtype you select sheet metal and you uncheck this default template. Okay, so here we have opened a new file and we have opened here a new file and we have opened a part, and the subtype we have selected sheet metal. You have unchecked the default template. You can give the name of your choice. So whenever you are giving name in the Creo software, you should not give space and underscore and hyphen. So you can give your name, okay, but you should not give space and underscore and hyphen, and click OK. So it is asking the template. Okay, by default there are two templates here. So can anyone tell me what is INLBS and MMNS difference? Yes, anyone? What is the difference between here INLBS and MMNS part? Yeah, one is English units, other one is metric system of units. So we generally use metric system of units and click OK. So is it clear up to this stage? So select MMNS part and click OK. So you can see the datum planes here. There are three datum planes: top plane, front plane, and side plane. And you can see all the options here. Among all these options, you can see only these three options are getting highlighted: extrude, planar, and boundary blend. Okay, we generally use only extrude and planar to create a base for the sheet metal. Okay, so once we create the base, all the other options will get highlighted. Okay, so let us create a base by using planar option. So you can directly select planar option. Okay, so I expect all of you to do simultaneously. Okay, so select planar and select the sketching plane. Okay, so you can select the top sketching plane, and as soon as you select the top sketching plane, you can see the interface has been modified to the sketch. So you can select the sketch view so that the sketching plane will become normal to the screen. Okay, and take rectangle, centered rectangle here, and draw rectangle with 100 by 100 dimensions. Okay, so you can change the dimensions. Hundred by 100. Okay, after changing the dimensions, you can get out of the sketch. So as soon as you get out of the sketch, it is showing the sheet metal model or the base or the first wall. Okay, you can increase the thickness of the first wall to 5 mm. Okay. Is it clear, everyone? So I'll repeat it for those who haven't followed till now. So I am closing this. So everyone, please focus again. Please listen carefully. So as soon as you open the ANSYS, Creo parametric startup window, you will have new button. You click on it. You select part, sheet metal in the subtype. Uncheck the default template. Give customized name. Okay, and click OK. Select the English metric system of units and click OK. So this is nothing but a template where they maintain either millimeters, newtons, or seconds units. Okay, so this is a startup page of Creo parametric sheet metal. So if you see here, there are only two buttons activated, extrude and planar. So you select planar here. So planar and extrude are used to create the first wall. So after adding the first wall, you can modify the first wall and create the flanges. So select planar, select the top plane, select sketch view, and select a rectangle and create the rectangle. And give the dimensions. You can either give the dimensions individually by double clicking on it, or you can select the sketch and select the modify dimension so that all the dimensions come at a time. So you have to uncheck the regenerate. So here you can select 100 by 100 as the dimension and so on. Okay. So after completing the sketch, you need to click on this tick mark so that you should get out of the sketch. So as soon as you click on this sketch tick mark, you will get a first wall of default dimension, that is 1 mm. So you can increase the dimensions like 3 to 4 mm. Here I am changing 3 mm as the thickness and press the tick mark. Okay. So if you observe here, after creating the first wall, all the options have been highlighted. Okay. So you can use extrude option to create holes on the surface. So I'm repeating again, select extrude, select the top surface, select sketch view, create hole. You can see a hole is created in the first wall. Okay. So by using extrude, also we can create the wall. So what I'll do is I'll simply delete this planar. Okay. So you can switch on the datum planes again. Okay. So here I'm selecting extrude, select extrude and select sketch. So you can okay. So you can see here directly I got a first wall like this. Okay. Is it clear, everyone? I'll repeat again. So I'll repeat the planar. There is a difference between planar and extrude. Okay. So planar, top plane, sketch view, create a rectangle of random dimension and give the thickness. Okay. If I select edit definition, okay. If you see the section is a closed figure in the planar. So we are using a closed section, a closed plane to create a first wall planar. Okay. So I'm deleting this first wall. Now let us look in the extrude. So you directly select extrude and directly select the plane on which you want to do the extrusion and directly select sketch view. Now in the extrude, instead of creating a closed figure, we try to create an open sketch. Okay, we try to create an open sketch. Okay, I have created this open sketch and I have completed the sketch by clicking this tick mark. So if I try to rotate this by pressing the scroll button on the screen on the mouse, you can see a planar wall. Okay, a wall has been created by using extrusion option by using an open sketch. Okay, is it clear, everyone? Yes. Now this is the base of anything. So to this base, I can create a flange or flat. Just flange is similar to extrusion, flat is similar to planar. Means what is the difference between extrusion and planar? In the planar option, we have used a closed sketch. Okay. Whereas in the extrude option, we have used an open sketch to create it. Similarly, in the flat, we create an open sketch. Okay. So let us try to create the secondary face. So select flat. So for creating flat or flange, we require a base. So that base can be created by using planar or extrude. If I select the bottom edge, I'll get a flat which is upwards. Suppose if I select flat and select the upper edge of this particular first wall, then I am going to get a flange which is downwards. Okay. So you can change the dimensions of it. If you, so we'll do one thing. I'll delete this extrusion wall and create a planar wall here. Planar, select the top face, sketch view, create a rectangle. Okay. Let the thickness be 3 mm. Now, so all of you focus here. I'm using flat, select flat and select the top edge of that flat so that you will get another wall which is downwards. Okay. Or if I select again flat and select the bottom one, I'll get a wall in this fashion. Okay. Now let us check the different options available in flat. Okay. So use right click on flat and select edge definition and select fit to view. So here you can change the width of that particular flat. Okay, and you can increase the height of that flat and you can also increase the angle. Okay. Yes, have you understood up to this? Are you able to do? Are you able to follow? Okay. Now, by default, the shape is rectangle. Okay. So if I select shape, if I select sketch, you can see whatever the sketch you are getting, that sketch is a closed figure. Okay. So let us check the same with the flange. Okay. So I am taking flange option and I am selecting any one edge. Okay. So I got the same. See, look, both of the things look similar, but I have created this one with flat and I have created this one with flange. And what is the difference between flat and flange? So flange, if I right click and click edit definition, and if I click shape and select sketch, okay. So you can see here, there is only a single line for it. Okay. And I can add another line or another curve to it. Just like extrude, this flange is also made up of a open sketch. Okay. But whereas this flat is made up of, if you right click on flat and select edit definition, if you select shape and select sketch, look at the sketch view. A flat is made up of a sketch which is closed, but whereas a flange is made up of an open sketch. I hope all of you have understood this. Yes. Now you know the difference between the flat and flange. Yes. Have you done it on your computers? So let us see some more options available in the flat. So I am selecting flat and edit definition and selecting the rectangular shape. All of you see here, by default, we have created a rectangular sketch. So that's the reason I got rectangle here. Instead of that, you can select trapezoid. Okay. You can change the dimensions of the trapezoid and you can also change the angle. Okay. So apart from that, you can also change it into L shape. Okay. So like that, you can change the shapes to T shape. So if I rotate it, you can see it is in the form of T. Yes. And you can also use user defined shape. So if I select user defined shape and select shape and select sketch and select sketch view. So I can select see, I have created this kind of shape. Okay. Is it clear up to this stage? Do you want me to repeat any step? Okay. So we have seen placement is nothing but on which face you are doing the flat. Shape means you can create the shape, whatever the shape that is there, you can create, or you can give some default shapes which are available here. You can create a rectangle, you can create a trapezoid, you can create L shape, you can create T shape or any user defined shape. So let us change it to the rectangle shape, or let us change it into L shape and press tick mark. You can change the angle here, keep it as 90, enter. Okay. And press tick. Okay. So again, I am editing flat. So let us see some more options. So you can adjust here so that you can see the way it has been bent. Okay. So you can give the radius from inside or from outside or any value. So I can give the thickness or the bend radius as 10. So you can see the radius has been modified. So earlier here, the bent radius here was the thickness, that is 3 mm. So I have modified it. Let us check again. If I click edit definition, if I give this thickness is 3 mm. This radius here is 3 mm. Okay. So instead of that thickness, you can give 2 into thickness, like 2 into 3 mm, that is 6 mm radius will come. Or you can give customized radius, that is 10 mm, so that its visualization is in better form. Okay. You can press press D for the object to fit in the screen. So again, there are so many options available in the flat where you can give relief. So in the relief is nothing but it gives the relationship between the wall and the cut portion. Okay. So let us see this. In the flat, you select edit definition, select relief. Instead of rip, you select rectangle. Okay. So rectangle thickness can be increased. So here in this portion, you can increase that thickness and make it 50. You can see this portion has been removed. Okay, or you can put it like 20, enter. Okay. Instead of rectangle, you can select around so that this will become the circular part. This part will become circular. Okay. Instead of that, you can also select stretch. If you select stretch, it will become in this form. Okay. So generally keep rectangle. If you are not willing to keep this extra part, you can put 50 and you can remove that part. Okay. So this unwanted parts can be removed in this fashion. Okay. So again in the flat, these bend allowances are not controlled by user. These are controlled by software. By default, it is selecting Y factor. Okay. So let us try to change this Y factor. So file, select prepare. Okay. You select model properties. Here you can select bend allowance is Y. So you can change it to K factor and you can select regenerate. Okay. Same thing can be done in the flange also. Flange, right click edit definition. You can change the shape of the flange. See how you got this shape. You can change the shape into S. You can change the shape of the flange into open type, or you can change it into flush type or any type. Okay. So again, right click edit definition, change it to the Z type, C type, or any user defined type. Okay. Yes. So what is the main purpose of doing this kind of sheet metal modeling is to use it for other options like punch, cut, etc. Okay. You can unbend this, and from here you can see the what is the exact sheet metal that is required to manufacture this component. I repeat again, unbend. So you can bend it again. You can bend back. When you select bend back, you will get the component which we have prepared. Okay. See, in order to prepare any component, you need to cut it in a specific form. So if you take a plain sheet and cut it manually, you will not be aware of how to cut it. So first we try to create a shape with this and try to unbend or flatten it and try to find out that profile, and thereby you can cut it by laser, etc., or manually. Okay. So bend back. I am deleting this bend back, or you can select flat pattern. Okay. So a flat pattern will be created. Okay. So we have seen 4 options today. So here we have seen how to create a first wall, planar and extrude. Okay. In the planar, you will use a closed figure to create a sketch, whereas in the extrude, you create a closed open figure to create a sketch. Okay. Whereas flat and flange look similar, but there is some difference between them. So what is the difference? What is the difference between that? Flat and flange. First, we will talk about similarities. Flat and flange are used to create these side walls for any wall. Okay. So for flat, you create flat by using a closed sketch. So if you see shape here, sketch, you can see a closed sketch here. Okay. But whereas when you create a flange, okay, when you create a flange, just like the extrude option, you create a sketch. Okay. So what is, we will see this bend here, edge bend. So we try to bend the edges here. It's not getting highlighted. So I'll close this and create a new file, part sheet metal. Okay. Now you can go to sketch. See, all of you look here. So we are in the sheet metal. What I want to do is I'll go to the part model without opening a new file. So all of you look here in the top corner, there is an option called operations. In the operations, there is an option called switch to part solid. So all of you open a new file. After opening a new file, select sheet metal and you'll get this window. In that there is operations. In the operations, you can switch back to the part solid. So as soon as I select part solid, all the options will be familiar to you as part modeling. So select any plane and select sketch sketch view, create a rectangle of random dimensions and try to extrude that rectangle with random dimensions. So basically you created a cube there. Okay. Again, you can go back to operations, convert to sheet metal. In that you can take shell, select the top face, increase the wall thickness to 5 mm and press tick mark. So now you have created this sheet metal with 5 mm thickness by using extrude option. Okay. Now I am using bend option. In the bend, I am using edge blend and I'll be selecting all the edges, outer edges here. Okay. And you need to rotate it and select all the other options. Okay. Press tick. Now we'll see today about rip option here. Select rip. There are 4 types of rip options: edge rip, surface rip, sketch rip, rip connect. So first select surface rip and select control button on the keyboard and select this surface. And you can see whatever the surface that has been selected, that has been ripped or removed. Okay. So only one surface has been removed. So you can select edged edge and select it's not coming. So I'll delete this. Again, select rip, edge rip. Sorry. Rip, you select surface rip. Select the surface. Press control. Select the surface. Press tick mark. Okay. Now what we can do is you can select rip, select edge rip and select the edges by pressing the control and press tick mark so that these edges are separated here. And you can select unbend option and see how it is bent. Okay. So basically edge rip separates the sheet metal at edges. Okay. Again, you can select rip, sketch rip, select any face, sketch view and select tick mark. Now you see this section has been created here. Okay. Now you can select unbend. Okay, you can see how it has been, a surface has been created. Yes, have you got it? Different rip options. This rip, okay, that for that another CAD model is required. So I'm not covering it right now. Okay. So what we'll do is we try to search for a sheet metal example. sheet metal example here. Okay. So what we'll do is we'll try to create a sheet metal with random dimensions. So we don't require, see, let us say this. Or I'll try to download it. So all of you assume the random dimensions for this sketch and try to create it. Okay. Yes. So assume dimensions for this sketch and try to create it. So how to create this? So how to create this is starting, you have to select the top view and select this base by using planar. By using extrude, you can create these two cuts. After that, you can add flange option and create this. Okay. Again, by using extrude option, you can remove these two materials. And like that, you can remove this and create all these parts and try to flatten this. Okay. So you have 20 minutes left. Try to complete this. Tomorrow we will see some more other options.